Hey everyone, welcome to this very quick video on perfect squares. If you're looking at this to help you study for an assessment or a reassessment, this is standard EE2. Alright, should be a quick video, so if you'll stay tuned, should learn a whole lot. Alright, so you're going to see some numbers listed here. I've got 5 times 5, 11 times 11, and 25 times 25. And so in all of these numbers, you'll notice that I have two instances or two factors of the exact same value. Well, when we take a number and multiply it by itself, we call it squaring the number. Hence the name of the video, which is perfect squares. So you're going to see, for instance, 5 times 5, that's equal to what? 25. 11 times 11 is 121. And 25 times 25, if you don't know that one off the top of your head, is 625. Okay, so since in all of these cases, I took the same number, multiplied it by itself, and that number was an integer, we're going to call these numbers here perfect squares. And perfect squares are numbers that have integers for their roots. And the root is the number we multiplied by itself to get that number. So in the case of 25, 5 was the root. Okay? Now, I want to point out one really important thing up front. 5 times 5 will give you 25, but also negative 5 times negative 5 will also give you 25 because a negative number times another negative number is a positive. Okay? So what we've just come up with here, these numbers are the perfect squares. And there's lots of perfect squares. You could fill in the blanks in between all these numbers I've given you. 1 times 1, 2 times 2, 3 times 3. And every number, on to infinity, if it's an integer multiplied by itself, then that resulting number is a perfect square. Alright, so now you should see some of these numbers that are familiar. We just worked out that 5 times 5 is 25, 11 times 11 is 121, and 25 times 25 is 625. We turned out that those numbers are perfect squares. Now, the other side of that, or going in the reverse direction, an inverse operation of squaring, is to take the square root of something. And square roots become really important in this grade, especially as we're talking about geometry, because we're going to learn something called Pythagorean theorem where you have to take the square roots of a bunch of numbers, so we need to understand what those are. So the square root of a number is the number that you multiply by itself to get that number. So for instance, the square root of 25 is 5. The square root of 121 is 11. The square root of 625 is 25 because those are the numbers you have to multiply by themselves to get those numbers. Now you're probably noticing this little sign over here. It looks kind of like a check mark with a tail. This is called the radical. And the radical, it's actually a neat word, comes from a Latin word radix, which means root. Like I said, it looks like a check mark. It looks a little bit like the box that we use for long division. It's not division though. It's very specifically a square root. And if you remember on the last slide, I talked to you about the fact that numbers have a positive and a negative square root. The radical usually means the positive root. Okay, so what we want is the positive version of that number. Now that's a really important distinction because sometimes, like on a test or something, they may ask you what are the square roots of 25, and in that case you need to recognize that 5 and negative 5 are square roots. But if you see this, that radical 25, that means the positive square root, so that would be correct to say that it is 5. Okay? Now, don't let your brain go out the window on this. A lot of people, when they see this sign, they all of a sudden start trying to divide by 2 or divide by 4 or something weird. That is a square root symbol. Okay? Okay, so here's the reason we actually talk about square roots. I mentioned to you already that it comes up a lot in geometry stuff because square roots actually represent something in the physical world. They actually represent the side of a square, hence the name square root, or a perfect square. Okay, so a square root actually represents the side length of a square that has a certain or a given area. So when I have, like my example square here has an area of 100 square feet. Think about how you find the area of a square. Well, area of a rectangle is length times width, but a square is a really specific type of rectangle in which all 4 sides have equal or congruent lengths. So when you want to find the area of a square, you take the side times the side, which gives you the area. Well, if we do side times side, that's actually the side squared to get the area. So a certain number squared gives us this 100. Well, what number times itself makes 100? Well, it's 10, because 10 times 10 is 100. Now, a lot of people make a really common mistake on this, which is that they start going, oh, if it's a square, let me divide by 4, because squares have 4 sides. That would make sense if we were talking about perimeter, and we would know we were talking about perimeter because that would be just feet to the first power. But if you'll notice, this is square feet. Square feet represents area. Okay, so when we're getting something that has to do with the area of a square and we want to know the side, we need to take the square root of it. Okay? All right, so here is a really common type of word problem that you'll see with perfect squares or square roots. We have a square garden has an area of 144 square feet. What is the perimeter of the garden? So some people know their perfect squares, they know their square roots, and then as soon as they see a problem like this, they see area and perimeter, they start doing all kinds of crazy stuff that's backwards of everything that they know about square roots. So the first thing we got to think about is, what do we know in this problem? Okay, we know we've got a square garden, and I always encourage my students when they're dealing with geometry and word problems, draw pictures. It takes just a couple seconds, and it really helps make things clearer. And I'm going to label everything I know. Well, all I know about this problem is that the area of the square is 144 square feet. Notice that I'm making sure to write that little exponent. That's going to remind me that this is an area and not a length. Okay? Now, what we said previously was that a square root represents the side length of a square that has a given area. Well, this square's area is 144 square feet. So to find the side, I'm not going to divide. I'm actually going to take the square root. So the side is going to be equal to the square root of 144. Well, what is the square root of 144? What number times itself gives a result of 144? If you said 12, you are correct. So each side of this square is 12 feet long. Okay? Now, we haven't answered the question because the question does ask, what's the perimeter? And some people like to go, oh, well, I'll just divide, I'll do this. You can't go straight from the area directly to the perimeter. You've got to find the side. It's kind of a stop in between. But now that we know the side, we know that perimeter is equal to all your sides added up. It's as if you were to walk around the edge of the garden, okay? As opposed to area, which is like if you were to cover the garden with something, it's how much stuff it would take to cover it. Perimeter is what you would get walking all the way around the garden. Okay? Well, perimeter of a square is going to be all of its sides added up. Since a square has 4 congruent sides, we're just going to add up 12 plus 12 plus 12 plus 12, or in shorthand, 4 times 12. And what is 4 times 12? Well, it's 48 feet. So that is the perimeter of our square. So notice it took us 2 steps. We had to do our square root part first, then we could use that to find the perimeter. Okay? So hopefully this video was helpful to you. If there are still questions or you need more help, please let your math teacher know and they will be happy to help you. And until next time, happy problem solving.